Hi, this is Mrs. Blake, and today we're going to talk about predicting the products of single replacement reactions. The materials you need for this video are a periodic table. So single replacement, which is sometimes referred to as single displacement, it's the same thing, is when an element replaces part of a compound in a chemical reaction. This can happen in two different ways. So I can have an element that is going to be a metal, and I can have an element that is going to be a nonmetal, and the replacement looks a little bit different. In an ionic compound is always going to be made up of a metal first, paired with a nonmetal. So if I have a metal being replaced, the metal is going to replace the metal. So if A is a metal, it is going to replace B as a metal. And that means that the metal is always going to be written first as my product, and the nonmetal is going to be written second. Some of my reactions, though, my element will be a nonmetal, and my compound then will replace the nonmetal, or my element will replace the nonmetal. And so A is going to sit in the second position because, again, your compound, an ionic compound, is always written with the metal first and the nonmetal in the second position. So if I'm doing a metal replacement, I am going to replace the first part of the compound. And if I'm doing a non-metal replacement, then I have to replace the second part of the compound. But just because I want a single replacement reaction to happen doesn't mean it will. So in order for an element to react, an element must be more reactive than the element in the compound. If a compound is in a very happy relationship, it's not going to dump its partner for something that is less desirable. So you must react with something that is going to be more reactive. And that's why in chemistry we use what is known as the activity series. The activity series, and this is specifically for metals, the activity series of metals is just metals that have been tested with the most reactive metals on the top and the least reactive metals on the bottom. And the rule is that in the activity series, an element is going to be able to replace anything that is below it on the activity series. So when we take a look at these, and you're going to see partial reactions, the steps to being able to do those reactions is I need to find my element on the activity series. So let's just take iron as the first one. This is iron reacting with copper 2 chloride. And it says to find the element on the activity series. So I'm going to go in my list of my activity series, and I'm going to go down until I find iron, and iron is going to be right here. And I am supposed to, the element will replace anything below it on the activity series. So in this compound, what I have in my compound is going to be copper. And since iron is a metal, it's going to replace the metal. Copper is a metal. And it will work if copper is below it. So again, I look at my activity series and I look until I find copper, and yes, copper is below it. That means that this reaction will happen. If this reaction happens, then iron is going to come over here and it's going to kick copper out. So copper is going to be an element. Oh, what do I know about an element? An element is going to be the symbol only. So if I am writing this, I don't have charges, I don't have subscripts, it is just going to be my symbol. And then I have to write a new compound. And what's my new compound? Well, iron is going to sit with chlorine. But it is really important that I am using either my periodic table, or in this case, I can use my activity series to figure out charges and write a new formula. You cannot steal the two from over here. So when I'm taking a look at this, I can go to my activity series, and this tells me that iron can be a +2. And I can use my periodic table and look up chlorine, and that's group 17, and it's going to be a 1-. And that means that those charges are going to cross, and this is going to become FeCl2. But please understand that that is not the same 2. This 2 belongs to copper and this 2 belongs to iron. And then it's an equation, I should balance it, but I've got 1 iron, 1 copper, 1 copper, and 2 chlorine for each. And so this is a balanced equation. So let's try a second example. So this time I'm dealing with nickel. Again, it is the element I'm going to find, and that's really important because if you start looking at your compound, you will have all of these reversed and therefore all of these wrong. So I'm going to find nickel on my list, and I'm going to come down, and nickel's going to be here. And nickel is trying to replace tin. Nickel will replace anything below it on the activity series, and tin happens to be right below it, but it is below it. So again, what happens is that nickel is going to come over and pour tin. Tin's going to be dumped and tin's going to be by itself. Again, tin can only be a symbol only. And then I am going to have nickel sit where tin is. But again, it is really important if I have nickel and tin. Nickel is now going to be a partner with chlorate, but I need to make a new chemical formula. Well, I can come over here and I can take the 2 from nickel and know that nickel is going to be a 2+ charge. And chlorate's going to be a polyatomic, and on my periodic table it says that chlorate's just a negative or a 1- charge. Those charges are going to cross, and chlorate needs to go in parentheses because chlorate gets a 2, and so this should be NiClO3, 2. All right. Again, really important to understand that this 2 has to have come from tin and this 2 has to have come from nickel, and they're not the same 2's, so don't automatically steal that number. And if I'm trying to balance, this one comes out to be balanced as well. So let's take a look at the next example. And this time I have copper. So that when I go up to my activity series and I find copper, copper is going to be right here. Now, copper is at the bottom of the activity series, and copper does not replace very many things. So when I'm taking a look at my compound and what am I trying to replace it with? Well, I'm trying to use nickel, and nickel's all the way up here. But copper does not replace nickel. So if in this chemical reaction, if an ion in the compound is above it, there is no reaction. So I am not going to predict products for this. Instead, I am just going to write no reaction because nothing will happen. I place a piece of copper into a solution of nickel 2 nitrate and it just sits there. It just gets wet. Now, there are a couple of other things that we need to take a look at with single replacement. So the next couple of examples take a look at a couple of exception type things that we need to pay attention to. So following the same exact steps, this time I have cobalt, and cobalt is my metal. But this time cobalt is trying to replace hydrogen. And wait, hydrogen isn't a metal. Hydrogen is a non-metal. But hydrogen behaves as a 1+, and therefore in this particular chemical reaction, it can be replaced. In fact, if you go up to your activity series, it is an activity series of metals, but you're going to find that hydrogen is on that activity series of metals. It works the same way. So in this case, I had cobalt, and so cobalt is up here, and cobalt as an element will replace anything below it, and hydrogen is below it. So yes, this reaction takes place, but this time it's going to replace hydrogen. Now, second note that you need to pay attention to. Hydrogen gets dumped, poor hydrogen, but hydrogen has another exception because hydrogen as an element is one of our diatomics. And so when hydrogen is an element, hydrogen is not going to be H, hydrogen is going to be H2. Now, that does not mean you're going to come back up here and put a 2 by tin and a 2 by copper. Non-metals are the ones that are diatomic. Metals are not diatomic. So really important that you're paying attention to hydrogen and putting a 2 by it, but don't follow that pattern for the rest of your metals. So cobalt is going to come in, and cobalt is going to form a new compound with chlorine. But I need a charge for cobalt, and again, cobalt can be a 2 or a 3, but I'm going to just steal it from my activity series, and this says that cobalt is going to be a 2. And this is with chlorine, and chlorine is a halogen, so it's a 1 minus. Those charges cross, and I end up with CoCl2 for cobalt 2 chloride. Well, this equation is not balanced. I have 2 hydrogen and I only have 1, so I'm going to put a 2 in front of here. But that's going to give me 2 chlorine, and so that balances out my equation. So, next example. When we take a look at water, water is made up of hydrogen as well, but this replacement is going to be a little bit different. Really important to pay attention to hydrogen because water is not going to behave as H2O. Water is going to behave as HOH. So when you get water in your chemical reactions, cross it out. Change water to HOH because your product is going to be a hydroxide, not an oxide. So same replacement, I am going to find my met element, and that's lithium. And lithium will replace anything below it, and just like above, it's going to try to replace hydrogen. Well, I'm going to go up to my activity series. I'm going to leave hydrogen there, but I'm going to find lithium, and I'm going to find that lithium replaces absolutely everything on my activity series. If lithium is my element, it will always react according to this activity series. So hydrogen is going to be dumped, but here's the difference in my products. Yes, just like above, hydrogen is the element that gets dumped, and that means it is going to be diatomic because hydrogen is a diatomic element. But now I am going to have lithium, but lithium is not going to be sitting with O, lithium is going to be sitting with OH. It is going to be a hydroxide. And since lithium is a 1 plus, it's group 1, and hydroxide is a 1 minus, I can leave the formula as LiOH. Now I do still need to balance this reaction. I have 2 hydrogens here, so I'm going to put 2 hydrogens here. That gives me 2 OHs, so I need 2 OHs. I've got 2 lithiums and 2 lithiums, and that should balance out the equation. So hydrogen is a diatomic. It can be replaced on an activity series of metals, and it is replaced as H2. And water is changed to HOH. So let's just take a look at 2 more quick examples here. I have silver, and silver is trying to replace potassium. So I'm going to go up to my activity series, and I'm going to find silver, and silver is going to be near the bottom. Again, not very reactive if you're near the bottom. And what is silver trying to replace? Well, silver is trying to replace one of the most reactive metals we have on the activity series, and it's not going to work. When I have silver replaces anything below it, if it is not below it, the only thing I need to write is no reaction. And the last one, my element is going to be calcium. And calcium is trying to replace sodium. So I'm going to go up to my activity series, and I am going to find calcium. And calcium is near the top, and it's trying to replace sodium. The element will replace any metal that is below it in a compound. So when I take a look at this reaction does happen. And if this reaction does happen, I'm going to have calcium come in, and calcium is going to dump sodium. Now, don't think about 2's. That's only hydrogen. So sodium is an element, and it's only the symbol. And then I'm going to have calcium, and calcium is going to be paired with OH. But again, I need charges to make my new formula. So calcium is a +2, hydroxide is a -1, and I'm going to cross those charges. And I need to balance my equation here, and I'm done. So metals replace anything below it on the activity series. Thanks, guys.